Good morning to all. I am T. Assistant Professor, Mechanical Department, Pondicherry College of Engineering in Nagarkoil. Last class I taught you about a problem based on the diffusion mass transfer. In this class I am going to teach you about a problem based on the equimolar counter diffusion. Equimolar counter diffusion. First we need to know what is equimolar counter diffusion. Equimolar counter diffusion. What is equimolar counter diffusion? When there is a mass transfer takes place, between two different area or two different vessels or two different tanks. The mass transfer takes place between two different area tanks or two different vessels, right? The flow takes place in both the directions, A to B and B to A, both can take place, and also the bad itself there is some name is there, equimolar. Equimolar means the equal number of molecules, equal number of molecule transfer molecules, equal number of molecule transfer between a vessel A to B or B to A, right? Equal number of molecules can transfer between vessel A and B, right? Now we can see the problem, right? Read the problem. Two large vessels contain uniform mixture of air as common on A and the sulfur dioxide common on B at 1 atmosphere and 273 Kelvin, but at different concentrations. Vessel 1 contains 80% of air and 20% of sulfur dioxide by volume or mole percentage, whereas vessel 2 contains 30% air and 70% sulfur dioxide by mole percentage. The vessels are connected by 10 cm inner diameter and 1.8 meter long pipe. Determine the rate of transfer of air, between these two vessels by assuming that a steady state. The mass diffusivity for the air sulfur dioxide mixture at 1 atmosphere and 273 Kelvin is 0.122 into 10 power minus 4 meter square per second. In this problem they given the different kind of data because it has two large vessels and the mixture of air and sulfur dioxide is in uniform, right? Uniform mixture, and is at 1 atmosphere and 273 Kelvin. But the concentration will be different. Right? Percentage of air and sulfur dioxide will be different. Okay, right? Then they given different values. What are values they given? The mass diffusivity. Only one value. The mass diffusivity, and that vessels are connected by a 10 cm diameter pipe with a 1.8 meter length. Okay, these are the data given. So the value of mass diffusivity is given. So comes under the diffusion mass transfer problem. Right? This problem they given the condition, steady state condition, and they given in the two large vessels, it's connected with the pipe. Two large vessels connected with the pipe have a diameter of 0.1 meter, that is 10 centimeter diameter and 1.8 meter long, right? Vessel 1 contains 80% of air and 20% of sulfur dioxide, and vessel 2 contains 30% air and 70% of sulfur dioxide, right? Then they given the condition, the mass diffusivity value 0.122 into 10 power minus 4 meter square per second, and the mixture temperature is uniform, right? The temperature is 273 Kelvin and the pressure is 1 atmosphere. Then what we need to find in this problem? Rate of transfer of air. Right? Rate of transfer of air, that is same mass flux only. how to solve this problem? First we need to identify the condition of this problem, right? For that, we need to check the problem first. The problem itself, they given the condition, steady state. The mixture takes place at steady state. So, problem is considered the steady state condition. But in this problem, they given two vessels, right? So, there is a flow from one vessel to another vessel, like that, right? For that, we need to select the suitable formula from the HMD data book. From HMD data book, page number 183. For steady state diffusion of component A into the stagnant component B, right? For equimolar counter diffusion only. For equimolar counter diffusion, same formula. Okay, no other changes. You need to write that formula. Here we know the value of diffusion coefficient and length value. Length is y2 minus y1, that is length, and temperature values. We didn't know the value of gas constant for air and partial pressures. We can find the value of partial pressure at the inner and first vessel and second vessel. Pressure at vessel 1. The solubility of partial pressure, the solubility of air at vessel 1 has 80%. So we can find the partial pressure at vessel 1. How means the solubility into pressure of uniform mixture. So we can get that 0.8 atmosphere pressure, right? After that we need to find the partial pressure at second vessel. Similar thing. The percentage of molar concentration, then solubility is 30%. So we will get the 0.3 atmosphere pressure. 0.3 atmosphere pressure. The RA is, what's the RA? RA is the gas constant for air. Gas constant for air. Why we are taking that air means they ask to find the rate of transfer of air. So that's why we need to take the value of gas constant for air. That value of gas constant for air is 0.082. 0.082 meter cube atmosphere per kilogram. Meter cube atmosphere per kilogram. Right? After this, we need to substitute all the values. In this equation. After this, we need to substitute all the values in this equation and find the value of NA, that is rate of transfer of air. Right? Before this, we need to find the value of area. In this problem, we can't be able to assume the value of area because they given the pipe diameter. With the help of that, we can find the value of area. By 4d square. With the help of this formula, we can find the value of area. After that, we need to substitute all the values: area, diffusion coefficient, gas constant, temperature, partial pressures, and length values, and find the value of rate of transfer of air. That value is 0.119 into 10 power minus 6 meters per second. Kilogram mole per second.